Okay, so the next topic is about the A0 to 11 protocol introductions. Upon completion of this course, you'll be able to describe basic A0 to 11 protocol knowledge, list A0 to 11 N advantage and also the AC advantage. Okay, we start from the first one, the A, B, and G. So this is those of the standard available for the A02.11. So A02.11 work at the 2.4 GHz. Okay, and here showing you the range. Okay, 2.4 GHz. Okay, the transmission rate is reached 1 megabit per second or 2 megabit per second. For the A, this version is work at 5 GHz. The transmission rate can reach to the 54 megabit per second. So the average throughput range is from 20 megabit per second to 36. So the distance is only can cover from 10 meter to 100 meter. So because all those standards belong to the WLAN, so the maximum range is only can up to 100 meter. Then for the B, this one is work in a 2.4 GHz. Okay, the transmission rate reached to the 11 megabit per second. Okay, the IEEE began to use A02.11b as an Ethernet standard, so which define the average transmission rate of 4 megabit per second. And average transmission distance is about 50 meter. So the G is just the upgrade version when compared to the B. Okay, they're using the same modulation, but the speed is greater compared to the B. But the range is still the same. Okay, it's about like 50 meter. Then the next one, they have some other the feature can support by the wireless. Okay, then A02.11i, this is for the security. R will be for the roaming. The S is for the mass networking. N will be another the version they can able to support the greatest throughput. And this one support the Mimmo technology, and we call as a multiple input, multiple output. And the last one is the AC. So this one is work at 5 GHz and support the maximum of 160 MHz channel binding bandwidth. So and this is the highest rate. Okay, the version A02.11a, the throughput is 54 megabit per second. So they're using the modulation technologies called OFDM. The data rates can work at 6, 9, 12, 80, 24, 36, 48, and 54. Then this is only work at 5 GHz unlicensed national information structure. Okay, for short we call it as a UNII band. The 5 GHz have 23 non-overlapping channels. A02.11b, the throughput is 11 megabit per second. So it only uses the DSSS to do the modulation. The data rate only supported in 1, 2, 5.5 and 11 megabit per second. So work only in the 2.4 GHz. So they have total of 14 channel. And why is 14 channel? Because the B in some country, like example in Japan, they have total of 14 channel available. But this doesn't apply to other country. Okay, so this is the optional one. So those non-overlapping channel is 1, 6, and 11. Because as we know, all the channel here, they occupy around like 22 megahertz. I mean for other version. In the A02.11b, the one channel occupy 22 megahertz. So since one channel occupy 22 megahertz, so try to avoid using the channel is non-belong to the non-overlapping channel, like 2, 3, 4, 5. Okay, like if I'm going to use this channel number 2, what will happen? So my channel number 2 will using this. Okay, this is my channel occupied 22 megahertz. So I will get some interference with the channel number 1 user. So to prevent this happen, that's recommended always try to don't using the adjacent channel. Okay, we're using a channel non-overlapping channel 1, 6, and 11 only. 11G, the maximum data rate can up to 54 megabit per second. This one is using the OFDM modulation. So the data rate is same as 802.11b. Fully compatible with 802.11b demeanor. And this is work at 2.4 GHz. There's total of only 13 channels and 3 non-overlapping channels. 802.11n. The maximum data rate up to 600 megabit per second. This version can support in 2.4 and also the 5 GHz frequency band. Support Mimmo and also the OFDM. Significantly increase the transmission distance and improve the network throughput performance. Okay, so this is one of the example product. The advantage of 802.11n. Transmission rate can up to 600 megabit per second compared with another version. Fully compatible with A, B, and G. And they have a high reliable wireless connection. So this is a picture to show how the 802.11n able to provide the high rate. So they're using the in the 20 MHz channel, the number of subcarrier is 48. So they try to using more subcarrier. Okay, more subcarrier allow you to do more modulation for the data bit. And then they have the code rate increase, short GI, high channel bandwidth, and more spatial stream. So this is a way how they're going to increase the speed of the 54 megabit per second and up to 300 megabit per second. Okay, I will going to discuss this one by one. Let's begin from the first. The more subcarrier. So as we know, in the OFDM, we can able to divide one channel into the multiple sub-channel. So this is happening in A and G. There's maximum 48 sub-channel available in 20 MHz. Okay, there's only 48. In the 802.11n, the maximum of 52 subcarrier are available. Okay, total up all is 52 subcarrier. Okay, so this is the reason why the speed can be increased from 54 megabit per second and become 58.5 megabit per second. The previous one, the code rate, they only can support half or maybe 3/4. With the version 802.11n, so they can change the code rate. The previous one is maximum is only 3/4. Now they can using 5/6. So with the 5/6, that means I only reserve 1/6 is doing the data error correction. That's all. So most of the rate, right, I will focusing on doing the modulation. So this is the reason they can able to perform even faster. Increase the physical connection on the rate by 11%. Just now it's 58.5, and now increase become 65 megabit per second. Short GI is then for the gap interval. So are the delay required for receiving or sending the wireless data between wireless data transmission? So for the normal GI, when we doesn't touch on any configuration, so the data rate will be sent out by this one. Okay, my first data and the second data. So in between them, they actually have a gap. So by default, for all the GI, they require the gap in between is 800 nanoseconds. Okay, before you can sending the next data. So they have this kind of gap. When we enable the short GI, so you're going to reduce the gap, the timer, before you can sending the next data. So now it's only require 400 nanosecond. So it doesn't require to wait for 800 nanosecond in order to send your second data. So the faster your forwarding speed. The common GI is 800 nanoseconds. After we using the short GI, then the previous one, the speed is 65 megabit per second, and now they increase another 11%. We can get 72.2 megabit per second. And also for the short GRI, it's not recommended enable on those of the scenario that got too many SSID or they got too many interference, because after we enable the short GI, they will cause a series of the interference and they cause your wireless connection become not so stable. 40 MHz frequency bandwidth. When want to doing the channel aggregating, the channel binding, it only can work in 802.11. Okay, only those products can support channel binding. So it allows us to combine two different channels. Of course, the channel must be adjacent to your current channel. So in order to do the aggregating, so they support up to 40 MHz frequency bandwidth. Then the next one, Mimmo. The previous version, the ABG, only using single input, single output. Okay, the antenna for the data transmission between the AP and also the STA. 802.11n, using two or more spatial streams for the data transmission between an AP and STA. If the STA also support multiple input and multiple output, Mimmo, multiple receive antenna and one signal processing technology can be used to reconstruct data sent through the multiple channel. So the Mimmo use other technology to improve the SNR of the receive end. This is the picture showing for the traditional the AP and the PC. So right now we saw from the AP here, they have one transmit antenna. Okay, it's using the one spatial stream. So they send to our STA. For those AP supported the Mimmo, so they have, example, I have 3 spatial stream. So the 3 spatial stream can able to send to the STA with 3 receiver. So they can able to increase the speed. Then the next one, what happened to those of the STA is only have one receive the antenna. Then we're going to using the beamform. So for most of the 802.11n product, it will support the beamforming. So why they're using the beamforming? Because on the earlier on we got discussed about the phase signal intonation and also the enhancement. So when I have the same phase, okay, this is the same phase angle right here. The two amplitude is different, so they'll cause the intonation. Okay, when it cause the intonation, then the signal strength will become weakens. So this happening when the PC receive this signal, the strength will be not so strong anymore. Okay, I mean the signal. So in order to strongest the signal, so this kind of product, you enable the beamforming to solve the problem. Okay, they will try to correct it. So using the beamforming, they try to correct your radio wave. They try to adjust. Okay, I think this is some of the error. So they're going to correct your amplitude here. Okay, and the other. When they're broadcasting, they measure at the same phase, the amplitude is the same. So when they broadcast to the A, the radio wave will be strongest, the amplitude, when they deliver to your the STA. The naming for the Mimmo. So they can using the name like 2x2 or maybe the 3x2. So they actually stand for the first number over here is indicators the number of the transmit antenna. The antenna we use to transmit the radio wave. Okay, the behind here, the number of 2 is referred to the receive. Okay, send and receive. 11 MAC layer protocol consume excessive bandwidth for link maintenance and protection, which greatly reduce the system throughput. 802.11 improve the MAC layer to minimize fixed cost and transmission loss caused by the congestion. So they're using these two, frame aggregation and the block acknowledgement. So 802.11n introduced a frame aggregation technology to increase the MAC layer efficiency. 2 types of the aggregation are defined. The first one is MSDU, the aggregation of the MAC service data unit. Then the next one, MPDU, the aggregation of the MAC protocol data unit. So these 2 types of the frame aggregation increase the rate to the different extent. So this is the first one, MSDU. So it will go to collect all the Ethernet frame to be aggregate. So for what we know, all the frame we're using on the LAN area, okay, they have example here. This is on the LAN area. We have 3 different Ethernet frame. Packet number 1, number 2, and number 3. So when they want to broadcast and transmit to the A, so right now, here is the AP. Okay, the AP try to process it. It's going to aggregate these 3 different packet into the one. But this is only happening when these 3 packet is delivered to the same PC. Then the MSDU will be happen. So we're going to select those of the frame with the same services. Okay, you need to make sure they're all using the same services. Okay, like example is this is for the voice or maybe for the video. All the packet must belong to the same services and deliver to the same PC. So they'll allow you to do the aggregating. So after you do the aggregation and attach the MAC header to this frame, deliver to our PC. Okay, so this is the MSDU. The MPDU. So this is based on the protocol. So even the packet frame here, okay, this is my packet data, packet 1, packet 2, and packet 3. All those packets is different services. So some of the services is maybe is using the voice, the packet number 2 is doing the video, and packet number 3 is for the normal internet data. So it's 3 different type of the data services. In the MPTU, it will allow us to aggregate these 3 different services together. Okay, so you're going to attach the different header for all the packet, okay, to separate their traffic. So they'll know, okay, the first MAC header will be used by the packet number 1. Second MAC header is for the packet number 2. Then this one is for the packet number 3. Okay, but of course, this frame is still delivered to the same PC, okay, the same SDA, but with the different services. Block acknowledgement. So to ensure the reliable data transmission, so the 802.11 requires that an acknowledged frame to be sent to respond to every received unicast data frame. So just now all the MPDU and the MSDU is delivered from the AP to the client. Okay, so this is one of the MSDU packet is already sent to the client. So when the client receives all those information, you're going to acknowledge. And also for the acknowledge, they don't need to acknowledge 3 times to the AP. It's required once only. 802.11ac. So 802.11ac work on 5 GHz frequency band. It's forward compatible with the 802.11 specification. Improve the physical frame structure and the channel management when the different bandwidth are used. So in terms of security, 802.11ac comply with the 802.11i security standard. So it's helped to implement the seamless roaming for the enterprise and the households. So the 802.11ac Wave 2 support the maximum rate up to 3.47 gigabit per second. With using this version, the 5 GHz frequency band will cause a less interference, and they have a highest access capacity. So this version is not only provided the standard Mimmo access, they also can provide the MU Mimmo. Okay, stand for the multi-user, multi-bar input, multi-bar output. So right here they have a Wave 1 and also the Wave 2 AC. For the Wave 1, they only can support up to 80 MHz channel the binding. For the Wave 2, they can support up to 160 MHz. The number of the spatial stream, the Wave number 1 only have 3. Wave 2 support 4. Both operate in the same frequency band. The theoretical rate for Wave 1 is only up to 1.3. Wave 2 can up to 3.47. And here is the MU Mimmo. Okay, this is the full name, multi-user, multi-bar input, multi-bar output. So use the expressive beamforming technology to control a signal propagation direction and the signal receive. Okay, so the Mimmo enable an AP to send the data to multiple SDA row, ensuring no interference between SDA. So the previous one, for those of the Mimmo technology, they only supported for the single user. Like this one, the user only have one receive antenna. So all the spatial stream here, you just focus on one antenna sent to the PC user. So with this one, you require to have the beamforming enabled. For those devices, the AP can support the MU Mimmo, so they can able to do the transmit to multiple PC user at the same time. So I don't need to focus on single user because I have 4 spatial stream, so I can able to stream to different user at the same time. So all the user doesn't need to wait. The MPDU expansion. To further improve efficiency and the reliability, A0 to 11 AC increased the size of the MPDU frame and also the MPDU frame from 64 KB to 1 MB. Okay, because the previous aggregating, they only allows to aggregate up to this size, and now the AC allow us to do the aggregating up to 1 MB. In the A02.11 AC, only support MPDU. And you also improve the performance for the RTS and also CTS. So this is happening to the A02.11N. A02.11N, it will go to using the primary channel and also the sub channel to deliver the RTS and also the CTS. In the A02.11 AC, so you're going to using the sub channel. Like example, right now I'm doing the channel binding, so I have total of 4 channels already in use. So you're going to using some other channel with less interference to sending the RTS. So A02.11 AC introduced 80 MHz and 160 MHz bandwidth. So only the A02.11 AC can achieve to this kind of the channel aggregating up to 160 MHz. So they're doing the channel binding. As you can see right here, this is the 20 MHz, and this is 40 MHz, 80 MHz. 80 MHz is combining with 4 different channels together. Of course, for the 160, you're going to aggregate 8 different channels to increase the bandwidth. And the last one is 80 plus 80. Okay, mean I'm going to select the different range of the channel. Like example, I'm using 4 channel on the first UNII band, number 1 here, 4 channel. Another 4 channel is right here on the other band, and I also can doing this kind of the aggregation. Comparison between A02.11 ABGN and AC. So from here, you will show you the theoretical the maximum rate and also the actual rate. Say 54 megabit per second for the air version, but the actual rate is only 22. To the B is 11 Mbps. Actual rate is around 5. To the G is similar to the air version. Okay, also is around 20 megabit per second. The N, when using the product, the A02.11N. So we check on the theoretical rate, can up to 600 megabit per second. But in fact, the actual rate we only get around like 100 meg. Okay, maybe slightly more than that. Then the AC wave 1 can up to 1.3. Actual rate is only 800 megabit per second. For the wave 2, is 3.47. Actual rate is up to around like 2.2 gigabit per second. So A02.11 ABG, this is at the beginning part, and I also did cover the technology advantage for 11N, and the last is for the AC.